Okay, guys, let's get a start on Chapter 5. Our first section is going to take a look at continuous probability functions. Now, a continuous probability density function uses function notation f of x. That is this guy right here. That is function notation that we use in algebra. And when you read that, you would say f of x. The graph of any continuous probability distribution is called a density curve, and any density curve must satisfy the requirement that the total area under the curve is exactly 1. There's a couple of important things in here. The graph of the distribution is a density curve, and the area under that curve will always be 1. Now, when we find the area under this curve, area is going to be the probability. So in order to find the probability of something happening, we are going to take a look at the area underneath our continuous probability density curve. I am going to change the color of that because I want it to stick out. I'll make it a little bit bigger because area will equal the probability. So here's our first example. We are going to consider the function f of x equals 1 over 20 for 0 less than or equal to x less than or equal to 20. There's a few things we need to unpack in here first. When you read this out loud, this says f of x equals (1 over 20) for x between 0 and 20 inclusive. When you say inclusive, that means you're using less than or equal to or greater than or equal to. The other thing we need to take a look at is what exactly this function is going to look like. Anytime you have a function that looks like f of x equals c, where c is any real number, this graph is always going to be a horizontal line. Intersecting the y-axis at whatever the value of that number is. In our case, there it is, our line intersects the y-axis at 1/20. So we get our horizontal line. Ideally, that horizontal line would extend forever in both directions, but we are restricting our domain. We're restricting our x values so that we only look at the part of the line that lies between 0 and 20. We don't care about the rest of it. Now, we are asked to find the probability, so we need to find the area of the rectangle. So we need this area in here. There's a reason I'm taking the time to shade this in. You'll find out the method behind my madness shortly. We need the area. Well, you guys know how to find the area of a rectangle. Area is still base times height. That has not changed for you guys. So here's my base. I know from the graph that the length of my base is 20 minus 0, or just 20. And then I need the height of my rectangle. Well, that's 1/20. When I multiply 20 times 1/20, I get 20/20, and that's the same as 1. So that means that the probability of landing inside this rectangle from 0 to 20 inclusive is 1. So now let's look at what happens if we change that interval. We are still going to use the same function. We're still using f of x equals 1/20. This time we're going to bound it by that line, by the x-axis, and the interval from 0 to 2 inclusive. So remember, f of x equals 1/20 is the horizontal line that intersects the y-axis where y is 1/20. We are only interested this time in the interval, or the space, between 0 and 2. So we still need the area of the rectangle. This is going to be, I'm going to move this down, because I'm going to give you two different choices in this case for your calculation. We can do base times height. In this case, my base would be 2 minus 0. I know that you guys can count. I know that you guys can look at that and tell me that it's 2 units long. But like almost everything else that I do with you, there is a method to my madness, so just bear with me for a few minutes. So my base is 2. My height is still 1 over 20. When I multiply, I get 2 divided by 20. That's the same thing as 1/10 when I reduce, which is equal to 0.1. This was method 1. I'll give you method number 2. Method number 2, we're going to look at the part divided by the whole. My part is this little base of my rectangle. The whole is the whole length of my original rectangle. That's 20. Regardless of your chosen method, you wind up with 0.1 for the area bounded by the x-axis and the interval from 0 to 2 inclusive. Now we want to find the area between f of x equals 1 over 20, so the same function that we've been looking at, the x-axis, and now our interval is from 4 to 15, inclusive. So our interval, or our rectangle that we want the area of, has shifted over a little bit. One more time, I'm going to give you both methods. We'll do method 1. And method 2. Method 1 means we're finding the area of the rectangle. So we're going to do the base. Times the height. The base of our rectangle is 15 minus 4. That's 11 for the length of our base. The height is, once again, 1 over 20. So when I multiply, I get 11 over 20. You can go put that in the calculator. and the area is 0.55. Method 2 is the idea of putting the part over the whole. In this case, the part is the length of our rectangle. We already figured that out. That was 11. The whole is the length of the rectangle for our function. Again, either way you choose, you end up in the same place. So then we go down and we want to find the probability that x equals 15. Anytime you have a line that looks like x equals some number, this is always going to be a vertical line. And it is going to cross the x-axis at whatever that number is. For our example, it's a 15. Now, I don't know how much you remember from high school geometry, but a line has no width. We also say that it has 0 width. That's important. This whole time, we have been finding the area of the rectangle, but we've had a start and a stop value, and we have found the area of the shaded rectangle. Now, we don't have a start or a stop. We just have a value. So, if I go look at base times height, well, the base is usually the length of my rectangle, but all I have is that vertical line, so my base length is 0. My height is still 1/20. Now, long ago, in a galaxy far away, you learned that 0 times anything is 0. So the area where our vertical line exists has an area of 0. Here's what that translates to. That means the probability of x equal to any number is always 0. For continuous probability functions. And your key for that is to look for the equal sign. If you have the less than or equal to, you have the intervals, that's fine. That means you're going to get a start and a stop, and you're going to have a shaded rectangle to work with. If there is an equal sign, that is your indication that the probability of x equaling that value exactly is always going to be 0. that brings us to the end of 5.1. I know you are super excited to get into 5.2, so I will see you again shortly.